Welcome to this Changing Conversations podcast from SGS. Over the course of 4 episodes, we'll be looking at how AI is having an impact on the testing, inspecting and certification industry. That's a bit of a mouthful, which is why we call it TIC, or some people just call it TIC, which is good because when you get something right, you get a tick. Whilst the concept of AI has been around since the early 50s, it's only in the last decade that it's become a major factor across almost every industry. From customer service to space travel, AI's fingerprints can be found having an effect on the way we live on our everyday lives. We need to narrow our focus today, and that's why this podcast will be focusing specifically on how AI is changing the TIC industry. To start us off today, we'll look at the unique challenges and thus opportunities for business in the TIC industry, and then try to figure out what the future holds. This will inevitably take us to our main focus of AI. I'm joined today by 3 guests. First up is Joost Vos, who's the technical specialist of NLP and data science at IBM. Hi, Joost.
Hello, Daniel. Good morning.
Nice to hear from you. I'm also joined by Nicola Colombo, Global Head of SGS.Comply. Hi, Nicola.
Hey, Daniel. Good morning, and good morning to everyone.
And finally, Tzveta Iordanova, the Innovation Coach at Emerging Technologies at SGS.
Good morning, Daniel and everyone.
Hi, Tzveta. Okay, I want to start today by setting the scene for the discussion and looking at where we are now. Tzveta, if you can kick us off with this by taking us through the most significant trends currently shaping testing, inspection and certification industry. How are these trends, particularly the adoption of AI, addressing the unique challenges and opportunities related to the industry's diverse and complex data services?
There are a few major trends that are impacting not only the TIC industry, but also any other. And these are, for example, digitalization and adoption of emerging technologies, increasing regulatory complexity and demands, globalization and market expansion, increased consumer awareness and expectations, sustainability transition, just to name a few. And the past few years, I've been focusing on digitalization and emerging technology, so I'll approach it from this angle. And one of the impacts of digitalization is that a lot of the traditional TIC services are now being performed in a digital, remote way, and emerging technologies are being integrated in core offerings, but that does not only apply for the TIC industry, it applies for other industries as well. Think about autonomous cars, connected devices, automated industrial systems. So the products, systems, and processes are becoming digital and more complex, and demand for TIC services that ensure the safety and reliability and compliance is escalating. Another impact of this trend is that new risks are being introduced, digital risk, emerging technology risk, and this, together with the increased consumer awareness, prompts regulators to come with more complex regulations at all levels, local, regional, global, per industry, per domain. And navigating those changes becomes increasingly challenging. Another angle is the TIC data. TIC industry is a very broad industry touching on every product, material, process, system in every industry that's being regulated. So there is a lot of data that's coming to the TIC industry, and with the digitalization, the volume increases exponentially, but also the types of data, the diversity of data, the formats of data. And if you add to this the time sensitivity, the geographical variability, the specialization, being highly specialized, technical, scientific, engineering data at a very granular level, it becomes really challenging to collect, process, integrate, analyze the data. It's almost impossible for humans to monitor how that's happening and to analyze it. And that's where AI comes to support us, because you know that data is food for AI, or there is no AI without data. So AI helps dealing with this data complexity, managing large complex data, integrating these heterogeneous, diverse data sets, but also enabling faster and more accurate analysis that prior to AI was done in a manual or eyeball principle, for example. But also it facilitates in efficiency gains by automating processes, tasks, and helps us in ensuring regulatory compliance, faster adapting to changes, customizing services, and many, many more applications. And Nicola, for example, has a really beautiful example how we leverage AI for food safety and compliance. But just to sum up, AI is really uniquely positioned to not only enhance, but also revolutionize the TIC services. And it's not only about services, it's really about enhancing quality, safety, and compliance, because regulations, of course, are regulating the highest risk. So all the decisions that we need to make that are data-driven decisions are really high stake and high risk decision. So in that sense, AI is really critical for TIC.
And if I can add a bit on this, that I think it's on the trend of we produce more data because we have more sensors, more digitalized services, but it's also posing new challenges also for AI in the sense that the decisions on which data can be processed by AI, because as you said, data are the food for AI, but we need to establish processes where we have a very tight control on what to feed with AI, because otherwise, once the data are inside AI, then the security and the privacy, it's a concern. So the role of the TIC industry is also to ensure that they are, let's say, controlling that AI, it's secure and it's fed with the proper privacy control.
Yes, fully agree. And also the outcomes are directly impacting the human health and safety and environment. So it's really critical, the data quality, the governance, and the quality of the output that comes from AI to be at its highest level.
Okay, that's great. Actually, now that Nicola has joined the conversation, it is over to you to introduce us to some of the real world examples of AI that you've seen at SGS. Could you provide some examples of that?
Yeah, for sure. That's I definitely bring my experience, the projects we've been working on in the last now almost 8-9 years since we started at SGS.Nicola Comply. So our mission was really to use publicly available information to generate actionable insights to manage the business risk, the product risk, the safety, and the compliance. So generating this such a vast volume of data, obviously empowering AI to generate these insights is the way. And we've seen an impressive evolution of the technology over the last 8 years since we started working on these challenges.
Okay, and what challenges did SGS.Nicola Comply specifically designed to address, and how is AI technology critical in overcoming these challenges?
Yeah, so I can share a couple of use cases. So, for example, if you are CPG industry, consumer goods, you have a brand to protect. You have to protect the consumers, and there's a lot of challenges and risk that comes from the supply chain, from the evolving regulatory change. So, for a large enterprise that has hundreds or even thousands of products in their portfolio, with hundreds of manufacturing locations, thousands of suppliers, different, especially in the formulated industry, you have products that are very complex, and they are, by nature, they are actually, processed. So they get, they are underneath in a transformation when they get formulated. So during this transformation, there's a lot of variability. So the safety, it's a paramount, also because those are food products, and ensuring that the companies has control over the process that happens inside the factory. It's a given, but there's a lot of things happening in the supply chain, and we have a lot of intelligence out there. We have the web that is a very rich resource of potential risk. For example, a supplier that was caught into a certain outbreak, or maybe correlating information about potential adverse weather event with a certain crop that can potentially increase the risk of certain contaminants being spread into a certain crop. That's because with AI, we are able to create this correlation and basically run certain predictions, or let's say forecasting of potential issues that can impact a certain a certain product or a certain ingredient or a certain factory for a given client. So our mission is really to provide these insights to help address and monitor this risk, and in a way anticipate what is at an early stage, what could be just an issue, but that can be easily managed. While if you capture this issue at an early stage, it might become already an outbreak, which means that if you capture the issue on a later stage in the value chain of a certain product, it basically means that you might need to be subject to recalls, or even then it has already reached the consumers and then potentially expose consumers to safety issues. So it's all about anticipating potential threats, potential risks that are happening on the surface of the supply chain, sometimes not directly evidently appearing, but just by correlating multiple data points, finding the opportunity to identify those and predicting this potential risk.
Yeah, thank you very much for that, Nicola. Joost, can we come over to you now? Looking more at the TIC industry specifically, can you start by telling us what are the latest AI models, including models like retrieval augmented generation, and how can these AI innovations help the TIC companies?
Yeah, sure. So since the introduction of transformer-based architectures back in 2017, we've seen a tremendous growth in not only the models, but also the size of the models. If you look specifically to text-to-text generation models, for instance, we have over tens and tens of thousands of different models that tap into specific tasks or specific activities that these models can carry out. So since the introduction of transformer-based models, foundation models, as we call them, there has been a tremendous growth in and advancement in the technology. They can find multiple applications within the TIC industry. As Nicola already mentioned, they're using publicly available data to compile solutions for clients. They get insights out of these documents. They can provide advices based on the insights that's available within these documents. You can leverage AI, but also generative AI to augment the process of getting these insights in a form that is easily consumable by the clients of SGS, of the Digital Compliance Service. I think we're moving a little bit away from, let's say, the fun side of applications as we've seen them with a number of very popular services out there. And I think, especially in 2024, what we're seeing is basically a reality check. And Nicola already alluded on it. So the data quality, that's really critical for the output of the AI, the complete pipeline. And you may see it as a supply chain from data up to the end product, which is a piece of advice or a piece of insights. The supply chain of AI, of generative AI, is critical. So garbage in is garbage out. It's still the same adage, which is very much true. And how do you control the complete flow from data to a solution that you provide to your clients? I think this is the year of the reality check. Another one is, so the development is multimodal models. So large language models, the models that handle text, are usually popular. And there's a reason for that, because the internet is full of text data, and text data was easily accessible. If you move to, for instance, audio or video, that's a little bit more complex. So you need to have more advanced models for that. And if you start combining modalities, as we call them, so text, video, audio, if you combine modalities, these models become really complex. We've seen already the introduction of a couple of these multimodal models over the past year, and this is probably going to expand over the next coming years. What we also see, and that's a little bit a contradiction. So if you look from 2017 up to now, you have this huge rise in the size of the models. So we went up from millions of parameters up to trillions of parameters. And the latest estimates for the GPT-4 models, we actually don't know how many parameters there are in those models, but usually it's in the hundreds of millions, up to potentially trillions. They are expensive, they're resource intensive, and they're sometimes fairly slow in response times. So if you imagine a mobile phone app that takes, 5 seconds to respond to a particular question, that doesn't have these, let's say, flabbergasted a user experience in the wrong way, I would say. What we see, especially in the text models, is they are getting more task specific, and the size is being reduced. And actually, we are talking about small language models. There are derivatives from these large language models, but they're tailored to a very specific task that they can carry out really quickly without the heavy footprint of these larger models. So we have quite a bit of GPU shortages in the market. GPUs are these graphical processing units that are needed to inference the models, and to use the models, and to train the models. If you don't have access to these GPUs, and especially if you foresee future applications of language models on mobile devices or on edge devices where you don't have these GPU farms that you can leverage, you need to go down in size of these models to leverage technology on smaller devices. One other development, and I think that is very, I'm really enthusiastic about that, is customized local models. So we're now seeing introductions of technology that allow you to specifically adapt the models to your specific use case. Because one of the typical characteristics of large language models is that they are trained on general knowledge. But this general knowledge is probably not that relevant for your organization. And if you look at the TIC industry, which is highly jargon specific, it contains a lot of regulations. And the chances are actually fairly low that specifically the regulations that do matter to your organization is in the training data for the model that you're using. So how cool would it be that you take a base model, you add your own organizational data, you add your own instruction layer to make the model as specific as possible for your specific tasks or activities where you would like to leverage the models. And you can leverage these models across the whole pipeline. Nicola.
Yeah, I just wanted to say that, in fact, I pair with what you're saying that, yes, your customized model is certainly a trend, but also having generative AI providing more and more capabilities to ingest larger context. So we've seen recently Google announced Gemini with 1.5 million tokens size. What does it mean? That if you have a model like that, you might not need to train it with the all universal knowledge of the web as it was done by GPT, or it's done by GPT that every 3 months you get updated knowledge. But basically having models that are efficient enough to basically in real time, in runtime, they are able to provide generative knowledge, generative answers, providing a context that might be very large. Let's say I have 10 books of mechanics, which is not my field, and I want to know what is the best engineering practice to create a certain part. Basically, I give these 10 books in one shot to the AI, and I get an answer only on that context. But obviously, the context can be big. And imagine how big can be in a large enterprise where you have maybe knowledge bases that are extremely big. But if the models can run with a context that that is actually defined by the user, so every user knows what the source and which context to feed the AI with, and then get the answer, as you said, in a few seconds. That's basically the way we see now the trend, also because it ensures the data quality, because it's the user decision on what are the contents to be provided, and also ensure the privacy, because in this way I don't need to train a model universally for everyone, and including copyright, its information, protected information, but I just basically query, let's say, prompt the AI. If I want to use a more language model term, I can prompt the AI, giving the context that it's something that I decide. So as a user, I control what is the context.
Yeah, I also want to comment on what you said. You said that the GPT models probably are not adding much value to our organization. And that's what I hear from our experts, for example. GPT models are really good for someone who is starting in a field. It serves like a skill level, or it's really good when you want to extend to adjacent domains or something that you haven't done before. but the experts don't see as much value. And you said it would be really nice, or how nice it would be if they can use their own deep domain data and knowledge to tailor these models. Is that done with the retrieval augmented generation models, or is it done with multiple models, like what you said, that there is a multiple?
So there are multiple ways. And I guess one really important distinction to make is that people frequently use a large language model or an application that was built on a large language model as a search engine. It's not a search engine. A large language model is a statistical representation of the training data. And all it does, and it does a really good job at that, is it actually is a very sophisticated type ahead engine. It predicts the next most probable word based on the previous sequence of words that are in the answer. So what you get is a statistically most probable answer, which is grammatically correct because the model was trained on producing grammatically correct answers, but it doesn't necessarily convey the correct factual answer because it's a prediction engine. It's not a fact generation engine. There's ways to optimize for that. And one very popular one is, Daniel already alluded on that, retrieval augmented generation. Instead of using the large language model to generate a complete answer, what you actually do is you incorporate your own corporate knowledge base in between the user and the LLM. The user types in a question, I want to know this and that. The question is then routed to your own knowledge base with curated documents that you really trust from your organization and are really key to your organization because the knowledge base contains everything which is important for your organization. It retrieves a couple of documents that contain bits and pieces of the answer. That goes to the LLM with the user question and the prompt, including all the text snippets that you retrieved from your own corporate knowledge base. It will be fed to the LLM with the instruction, summarize and create a easy to consume answer, but give me the links back to the documents where the bits and pieces of the answer were found. This tremendously increases the accuracy of the answer. It tremendously decreases the percentage of hallucinations because what you actually do is you can instruct the system. If you don't find any documents that can provide an answer to the question, don't answer at all. One of the biggest limitations of LLMs is if you ask them a question, you always get an answer. And we all know these discussions where it's better to just not give an answer on a question. But LLMs don't do that. So you really need to instruct a system to provide reliable answers. And sometimes there is no reliable answer. And then the LLM should actually be told, don't answer at all. So RAG is one of the ways to improve the accuracy and performance of the system. And there is a couple of other methods. So nowadays, prompt engineering is one of those methods. And Nicola already alluded on it. You can load books into the context length of a model and then start asking questions about what you've put in the context. That's quite labor intensive. You need to load the books each and every time in the context window, which is also a cost discussion. So the most technology providers calculate based on the number of tokens. It's a certain amount of text that you use as an input for the model and you pay for the output. So input, output, that's the cost picture of using LLMs. What if you were able to make a model as specific as possible for your use case? You don't need to have this huge context window. So there's multiple ways to adapt the model to your own needs. And one of those is prompt tuning. So you start feeding the model with input-output examples. What you basically do is you create, as we call it, an accessory model that pre-processes the prompt of the user in a way that's relevant for your organization and then is passed on to the LLM and it gives you the answer. And you can position a knowledge base in between there, but that's one of the ways to, for instance, influence the tone of voice of the LLM output. And the second option, it's a little bit more expensive and a little bit more labor intensive, is to fine-tune a model. What you basically do is you take a base model, you take your organizational documents, you do the fine-tune within the process of fine-tuning, you actually change the weights of the parameters in the model in a way that's suitable for your organization. It works really well.
Which is, if I can add something in there, unfortunately, that the fine-tune of the model we've seen in most of our clients, which are corporate, it doesn't work very well because there is not a single person that can have access to all the documents of a company. So it's so granular, the access. Now we ourselves in SGS experience, we use like knowledge bases like SharePoint and so on. It's a nightmare, the complexity of access control. So there is not really a universal use case where you can say, okay, this is the company knowledge, let's give it to there. You will have to fine-tune hundreds of models. You will have to fine-tune the model that has the knowledge of HR policies, the model that contains the policies of how to request a leave off time. So you will have to create hundreds or thousands of models that are basically trained with the knowledge that has that particular access, and then you give access to that model based on the role of the person. And this is basically happened to become unfeasible. That's what we've seen with companies. That's why I see that creating pipelines that allows, based on the context where I'm sitting into a data space. Since I'm sitting in the data space, it means I have the right to see those data. Now let's get my virtual assistant AI to provide me the feedback. So that's very much similar to the TIC case, because in the TIC we have knowledge that it's so segmented by customer. Consider that we treat a lot of confidential information about our client product services that we test, we analyze, and so on. So it's very difficult to do even within one single TIC company to do a model that works for everyone, because it will have to train with data that are that have different ownership by client, by segment, and so on. That's basically the challenge we have to overcome. And I think RAG, it's going in the right direction.
Yeah.
As we draw this episode to a close, I must say it's been an enlightening experience, and I hope it has been for you too. Thanks for tuning in. Don't forget to subscribe to our podcast to stay updated with our series. In our next episode, we'll delve deeper into today's topics with a stimulating debate amongst our experts. I'm looking forward to bringing you more insights in our upcoming discussions. I'd like to say a special thanks to my three guests today: Joost Vos from IBM, Nicola Colombo, and Tzveta Iordanova, both from SGS.